name is Evgeny Filipov. I'm a PhD student at the University of Illinois. My advisor is Professor Glaucio Polino, who's currently at Georgia Tech, but still affiliated with U of I. And we've done this project in collaboration with Professor Tomohiro Tachi at the University of Tokyo. Origami is an old Japanese art form, and it is the use of thin sheets, typically connected by fold lines, to be reconfigurable to be adaptable types of systems. Origami engineering has really taken a leap in the last few years. The most exciting thing about these structures is that you can take these thin sheets, which you'd think are very flexible, but by coupling them into this zipper type of coupled tubes, we can now create stiff structures. These structures can be much more efficient because, of course, they're using thin, flexible sheets, but now the overall structure is substantially stiffer. One of the most natural advantages that we can think of is these types of structures which can be stowed into a small compact place, but then can be deployed to serve a function of a larger or perhaps stiffer structure. For example, if you had a box that you wanted to use for moving, you could easily compact it into your closet and it would take up essentially no space, but when you wanted to use it, you'd be able to deploy it into this type of nice, large, stiff structure. They can change their shape, they can change their configuration to be multifunctional. For example, in a structure, you could use these to create a shading system on a building. So during the day you have shading, but at night you open it up and you actually get more light. You could use it to control the heat and air through a building. A real big benefit to this would be having these structures pre-assembled in a site, and you could then ship them in a nice compact place, but deploy them into this large multifunctional structures. If you were to launch a satellite that carried these types of deployable arms or booms, once you deploy them, they would be substantially stiffer and can now carry different types of equipment. They could be used to deploy solar arrays in space, and they wouldn't vibrate or twist when they're deployed. Here we've only used paper for our proof of concept models, and these models can now carry much larger amounts of weights than just a single piece of paper would. But imagine what we would be able to do with using plastics, steel, or other types of engineering materials.